So my name's Dr. Jim Steele. I'm the team leader for Health Data and FHIR at the CSIRO's eHealth Research Centre. So CSIRO, for those who have not run across our organisation before, is Australia's national science agency. So we cover a very broad range of sciences, from boats going down to Antarctica to different breeds of wheat and barley, right through to eHealth. And the eHealth domain is covered by the eHealth Research Centre. And the team I lead is the Health Data and FHIR group, which is within our Health Informatics group. And we cover a range of things, and most particularly clinical terminology. So we've been working on clinical terminology for more than 10 years, and the software tools that support the productive use of terminology for health data interoperability in particular. A lot of that has focused on SNOMED CT historically, but more recently we're involved in a broad range of terminology across the eHealth space. This includes our Ontoserver clinical terminology server product. I'll talk a little bit about Ontoserver at the end of this talk. But the first part of the talk, I'll be talking about the resources that are used in the FHIR specification for dealing with terminology, specifically the ValueSet, CodeSystem, and concept map resources. And so the first part of my talk is not specific to Ontoserver. It's about the FHIR specification and how it does terminology. Ontoserver implements all of the FHIR terminology services API. So all of the things I do present are supported in Ontoserver, but they may also be supported in other products. So using these resources doesn't tie you to Ontoserver in any way. It's very much a standards-based way of doing terminology. I'll also mention that this is part of a pair of talks that I'm going to be doing. So I'm giving this talk tonight about the FHIR terminology services resources. Next week, I'll be giving another talk about the FHIR terminology services operations. And these are really how the resources get used for things like data entry, data validation, and so on. So I'd encourage you, if you're able to come to next week's talk, to do so. It really is complementary to what I'll talk about tonight. I will mention those operations briefly tonight, but I won't go into the details of what parameters they take, how to use them, and what they help you do. So that will be dealt with in next week's talk. So to begin with, why are we interested in terminology? So when we're doing health informatics and when we're exchanging health data, terminology really is the basis of shared meaning between different systems. So when we exchange structured data between systems, things like FHIR structured definitions or open-air archetypes or the information model that we're exchanging represents the skeleton of the data that we're sending across, but it's the terminology that's really the muscles. It's the terminology that differentiates a diabetes diagnosis from a cystic fibrosis diagnosis, that differentiates a COVID vaccine prescription from an aspirin prescription. It differentiates a knee reconstruction from an X-ray procedure. So terminology really is a really important part of the information that we exchange when we're doing health data interoperability, when we're sending health data from one place in the health system to another. Particularly in a large integrated system, it's a really valuable thing to have a single reference for the terminology that we're using as well. So that when we're exchanging codes, and there are different parts of the system that are using those codes, those different parts have a shared understanding of what those codes mean, of which version of SNOMED they're using, or which version of ICD-10 they're using, or which version of LOINC or a proprietary code system that they're using. So it can be a really valuable thing to have a single point of reference in a large eHealth system for the terminologies that we're using. And another characteristic of terminology that can be really useful is using externalized terminology. So rather than each part of a large health ecosystem having its own terminology functionality, which might behave differently, it can be really advantageous to have an externalized terminology function in the system. This makes it much easier to update the terminology when, for example, a new version of a terminology is released. You can update it in only one place, and then the use of that terminology will be consistent across all of the different parts of our system. So these are some of the things that can be useful in the way that we deal with terminology. And FHIR gives us a single API for dealing with these, dealing with terminology across the system. So some of the places, if we are using FHIR, that terminology will be used. And actually, I should mention that the use of the FHIR terminology API doesn't necessitate that you're using FHIR for all of the rest of your health data. So we've seen, we at CSIRO have seen a number of people using the FHIR terminology services API in conjunction with systems like OpenEHR or with HL7v2 or CDA implementations, because the FHIR terminology services API really is a very good API just in and of itself for dealing with terminology. It's not necessary to be using FHIR for all of the rest of your health data to get value out of the FHIR terminology services API. Of course, if you are using FHIR for the rest of your health data, then there are some additional things that you can do with the FHIR terminology services API, including validation. But it's useful for searching for codes, finding information about codes, translating codes, validating codes. These are things that you need to do regardless of whether you're using FHIR for your health data or something else for your health data. So some of those use cases, if you're doing data entry, the FHIR terminology services API gives you ways of quickly finding the right code to record, whether that's using a type ahead widget, for example, or just providing a list of codes that can be rendered in a drop-down widget or something like that. It provides help for the validation scenario. So when you receive a code or a set of coded data, then checking that those codes are appropriate for the fields in which they've been provided. So for example, that you don't have a medication code appearing in a field where you expect procedure codes. For display and understanding, so if you receive a whole bunch of codes, the FHIR terminology services API can help you look at those codes and see how they relate to one another, whether that's by hierarchy or whether there's some other relationship that exists between those codes. For mapping is always important when you're dealing with terminology data. When you're dealing with coded data, it's very rare that you can use a single code system across a large health system. It's usually the case that you'll be required in some circumstances to use one code system and then in another to map that across to another code system. So FHIR can help with supporting that mapping. For analytics, when we have coded data, we often want to try and understand that data by grouping it into categories or sort of analyzing those codes. And the terminology services API can help us with that as well. And with authoring, so whether it's needing to create some maps between different code systems or construct some value sets that we're interested in for a particular clinical context maybe, or to create a proprietary code system to represent some codes that we're using in a certain jurisdiction, for example, FHIR can help with that as well. And for the case where you are using FHIR for the rest of your coded data, if you're implementing a FHIR server, then a terminology server can help support some smarter ways of using that FHIR resource server. So for example, being able to search for condition resources and not just find condition resources with a certain code, but to find conditions that are that code or any of its descendants, for example. Integrating a FHIR server such as Happy or the .NET API for FHIR or Volk or one of these servers, integrating them with a terminology server can help support richer forms of search and validation. So when we are using FHIR, there are 3 data types where we will see coded data, where we'll see terminology being used. These are the code, coding, and codable concept data types. So where we see the code data type, all we will get for that is just a code. So we won't be told which code system that code comes from, because that data type is only used in circumstances where the coding system is fixed by the particular field that we're interested in. So for example, if we look at the administrative gender field on the patient resource in FHIR, It's a code type because it's not possible to have values from other coding systems. It has to come from the administrative gender code system if it's being used in that gender field. The second data type is coding. So coding, when we express a coding, we express the code itself and also the URI of the code system where that code is taken from. Those two pieces are mandatory. In addition to those, we can also specify the version of the code system. We can also specify the display text for the code, and we can specify a Boolean flag to indicate whether or not that code was directly selected by the user, as opposed, for example, to being mapped across or inferred by an AI method or something like that. So that coding data type is reasonably commonly used in the FHIR spec. But the really most common data type that you'll see in the FHIR spec is the codable concept data type. A codable concept consists of multiple codings as well as text. And when we use multiple codings in a codable concept, the intention is not that we put together multiple codings that represent different concepts. So we wouldn't expect to have in a single codable concept a code for a knee reconstruction and a code for a vaccination. What we would expect to see in a codable concept when we have multiple codings, for example, is we might see the SNOMED code for a knee reconstruction and an ICD code for a knee reconstruction. So they're equivalent concepts. We're just expressing multiple codings, usually in different code systems, or we might see something that's where one thing has a sort of orthopedic procedure and the other one has knee reconstruction, where one is a more specific version of the other. We don't put in codes that are in conflict in a single codable concept. The other place where we'll see terminology data in the FHIR API is in the search parameters that are defined for each resource. When we're searching for search parameters that expect coded data, you'll see that the token data type is used for the search parameter. And the token data type can have a number of syntaxes. So we can either specify the URI of the code system and then a pipe character and then a code. And in that case, the search parameter must match both of those things, both the URI and the code. If we just put in the code with no pipe or system, then it will match that code in any code system. If we put a pipe and a code, it will insist that there be no code system, which is an unusual case that you really wouldn't expect to see very often. If we put in the search parameter a system URI followed by a pipe character, we're saying I'm searching for any code that comes from that code system. And then we can also use modifiers with these token typed search parameters. So the colon text and colon not parameters are the same as are supported on all the other FHIR search parameters. The interesting ones are the below and above search parameter modifiers. So this allows us to search, for example, for the diabetes code and any of its descendants, or in the above case is a strange one. It allows you to search for diabetes and any of its parent or ancestor codes, which isn't usually very useful, but is something that you can do in unusual circumstances. The other interesting modifiers are the colon in and colon not in modifiers. So these allow you to, for example, search for a condition where the code is in and then provide a value set URL. So you might have built a very detailed value set describing all of the notifiable diseases that you're interested in, or all of the, you might be searching for medications where the code of the medication is in some schedule of restricted medications. Then you can provide the URI of that value set, and the search will return any resource where the code is in that value set. And this probably behind the scenes will use some of the terminology services operations that we will see discussed next week. So this is a quick example of a FHIR resource with some examples of those three data types of code, coding, and codable concept. So this is a fairly simple encounter resource. The second line there is the status field, and the status field here is a code typed field. And in this case, it has the in progress code, and it doesn't say which code system that's from, because the status field of encounter is always bound to a particular code system for encounter status. The next line we can see is the class element. And this is an example of a coding typed field in FHIR. So in this case, we can see that it defines both the system URI for this v3 act code and also the code itself, which in this case is AMB. It could also have expressed the version of that code system, the display text for the code, and whether it was user selected. But in this case, those things have not been defined. And then the third data type that we can see here is the reason code field. So this is a multi-valued codable concept. So this has multiple codable concepts. In this case, we only have one codable concept, and within that codable concept, we have two codings. So we can see that there's the SNOMED code. I can't remember which what that's the code for, but we can see that the SNOMED code is in there, and we've chosen to specify which version of SNOMED that's come from, and that was the code that the user selected. And in addition to that SNOMED code for the encounter reason, we can also see there's an ICD-10 code, UO7.2. And we can actually work out what these codes represent, because in addition to the codings in the codable concept, we also have a textual representation of the codable concept, which is suspected COVID-19. So both of those are codes. So the SNOMED code for suspected COVID-19 and the ICD-10 code for suspected COVID-19. So that's where we're going to see those coded values represented in other FHIR resources. But the three resources in FHIR that deal specifically with terminology are these three. So CodeSystem, ValueSet, and Concept Map. Now you can see on this slide, I've put some purple boxes with N in them next to CodeSystem and ValueSet. And that's because those are normative resources in the FHIR spec. So as of the R4 version of FHIR, which is a year and a half old now, there are a small number of FHIR resources that are normative that are not going to change from now on unless something is really, really wrong with them, which is extremely unlikely. And I think there are about 12 of those resources, and 2 of those are CodeSystem and ValueSet. Concept Map is a little bit less mature. I think it's at FHIR maturity level 3, which tells you that that resource has been through some connectathons, it's been tested a bit, but it's still subject to a little bit of change. And if anyone's interested in some of the changes that we're expecting to see in Concept Map, then please ask in the questions, and I'll be happy to get to that at the end of the presentation. So these three resources, CodeSystem is a set of concepts with some coherent meaning. So that might be a standard code system such as SNOMED CT or ICD-10 or LOIC, or it might be a proprietary code system that's only in use in a certain jurisdiction, or even only in a certain hospital or a certain clinic. Every code system has a URL and a version, and these are important because that's how we refer to code systems from other resources, is by that URL and version. It also has a lot of the standard metadata that you would expect. It has a name, you can say who's published it, you can say the date it was published, whether it's experimental or not, you can give it identifiers and so on. More from a functional point of view, the code system can expose a number of filters, and it can define a number of properties. And when a code system defines some properties, that means that the concepts within the code system can then provide values for those properties. That's the real main body of the code system resource, is those concepts. So every concept must have a code. They will usually have a display text as well. They can have a definition. They can also have a number of synonyms as well. And we'll get into how those get represented in the code system resource in a moment. The second resource is the ValueSet resource. So the ValueSet represents a selection of codes drawn from one or more code systems for use in a particular context. Usually we build value sets with codes from a single code system, but there are certain scenarios such as analytics where it's really useful to be able to build value sets that include codes from multiple code systems. So that is possible. And later in the presentation, I'll get into the ways that we build up value sets using rules to determine which codes are or aren't in the value set. And then the third resource is the concept map resource. So the concept map is how we express a mapping from codes in one value set and codes in another, as well as the relationship that holds between those codes. So as well as saying that there is a mapping between a certain code and another code, we can say whether that mapping is an equivalent relationship or whether one is narrower than another or one is broader than another, for example, or whether it's just some other kind of relationship. So those are the three resources that we're interested in. To dive into to just have a little bit more detail of those. Oh, actually, before we do, hopefully most of the people here have encountered FHIR before and are aware of the basics of how to interact with a FHIR server. But this is just a very quick recap that the way we interact with FHIR resources is using what are often called the SCRUD interactions. So we can search for those resources. We can create those resources using a HTTP post request. We can read a resource using a GET request, or we can do a versioned read, which is also a GET request with a slightly different URL. We can do an update request using an HTTP put, or we can do a delete request using an HTTP delete. And the same is true for the terminology resources. So the first scenario that we're interested in is authoring terminology resources. And this is really what I'll talk about in this presentation. The other scenarios are really much more in the presentation I'll give next week. So there are a lot of scenarios where we might need to author terminology resources. So if we're creating a new user interface for clinical data entry, then we may need to create value sets for each of the fields to control what codes are actually selectable for that particular field. It's somewhat unusual, particularly with large code systems, to allow the user to enter any code from the code system. So for example, you would never have a field that allowed someone to enter any SNOMED CT code, because they could enter a procedure code, a medication code, a drug code. It could be a gender, it could be a type of hospital facility. SNOMED CT is far too broad, and the same is true of LOINC and the ICD-10. In most cases, we want to narrow that code system down to a specific part of that code system that's permissible for a certain field, and we can use value sets to do that. If we're creating FHIR profiles, we often need to create new value sets to bind different parts of the profile to. If we're creating or representing proprietary or local code systems, we will need to create a code system resource to represent those. And in that case, or in other cases, we'll often need to create concept maps for describing the mappings between different coding systems. So that code system resource is the first one we'll look at. As I said, it's got a bunch of metadata. The most important is the URL and version that we'll use to refer to that code system from everywhere else. There's a lot of other metadata that you can use. So you can define the name, title, identifier, status, and so on. These fields are really valuable from a governance point of view, but they don't change the behavior of the code system and its operations. This next set of elements that you can define on a code system, these elements do change the behavior of the code system resource. So you can say whether it's case sensitive, whether the codes are case sensitive, whether the code system is compositional, meaning it has some sort of grammar where you can make up new codes by combining codes, such as in SNOMED CT, and in some cases in ICD-10, not usually, but in some cases. Hierarchy meaning tells you whether it's a subsumption-based hierarchy, and it is a hierarchy, or perhaps just a classification, or whether the hierarchy that you see in the codes actually has no meaning at all. Version needed goes to a thing that's often called concept permanence. So this is whether a code can change its meaning from one version to the next. in which case you really need to specify which version of the code system you're using every time you provide a code, because the meaning of a code could be different depending on whether it's version 1 or version 2, for example. The content element tells you whether this code system resource has all of the codes in the code system, or whether it's just an example of some of the codes in the code system, or maybe there's no codes present at all, and the code system can tell you that using that content field. Supplements is a field I'll get to in a moment. I've got a slide dedicated to that. And counts just tells you how many concepts are in the code system resource. Then we can define properties and filters. So as I said, this allows us to attach extra information to each of the concepts in the resource. So what we can see over on the right here is an example of a code system resource. This is one that I've made for representing the jurisdictions in Australia, so the states and territories. So it's got a lot of the metadata things here, and it's defining two properties, one called capital, which is a string typed property, which allows us to express the capital of each jurisdiction. And then the neighbor property is a code typed property that allows us to say whether one jurisdiction is a neighbor of another jurisdiction. Of course, the body of the code system and the most interesting part is the concepts in the code system. So these can be expressed in a hierarchy. So we can see over in the example on the right-hand side there that we have nested concept elements. So what that's saying is that the AU concept here is a parent of the AU state concept, which is a parent of the WA concept. That's one way of expressing hierarchy in a code system resource. The other way is to populate the parent or child properties of each resource, which are implicit properties that you can use to describe hierarchy. And that's really useful, particularly if you have a code system with what's called polyhierarchy, where code can have multiple parents. If that's the case, you can't express that just using JSON or XML nesting. So you have to use the parent and child properties to express that polyhierarchy. Each concept will have a code, obviously. It will have a display text. It can have a definition, which is a more detailed definition of the concept. It can have a number of designations, and designations are useful either for defining synonyms. So the example I have over on the right defines a designation which is a synonym for the Western Australia code. But you can also do translations in designations as well. So alongside use on the right-hand side here, you can put language, which tells you what language the designation is for, which is how you can express translations. And then we can also define the property values. So we can say what the capital of this jurisdiction is, and what its neighboring jurisdictions are. As I said, I'll get into the operations from the Terminology Services API in more detail next week, but just as a hint of what those are, on CodeSystem, there's a lookup operation, which we can use to retrieve information about a concept. There's a validate code operation on CodeSystem, which tells us whether a concept is a member of the code system. And there's a subsumes operation, which tests two concepts to tell us whether there's a subsumption relationship between those two concepts. So whether concept A subsumes concept B, or concept B subsumes concept A, or they're the same concept, or there's no subsumption relationship between them. And then the closure operation, pardon me, is actually defined on concept map, but it's really about code systems. It allows us to pass in a whole bunch of concepts over time and to see what all of the subsumption relationships are amongst all of those codes. So rather than doing it pairwise, we can do it in a large group. Earlier on, I mentioned a code system supplements element, and code system supplements are a new feature in the R4 version of FHIR. And they allow us to define kind of an addition to a code system that already exists somewhere. So if, for example, we've got a LOINC code system and we want to add some extra information into it, we can't change the actual LOINC code system because that's published by Reagan Streif, it's fixed. But what we can do is we can define a code system supplement and then use that supplement alongside that LOINC code system or any other code system when we want to use value sets or use it on our server. And this allows us to do a number of things. So we can override display terms. So if we decide that some of the concepts don't have the display terms that we like to use in our context, then we can override those. We can add designations, and this is a really powerful thing for doing language translations. So if we're using a code system where we really like the concepts and the hierarchy that they're in, but it's in the wrong language for us, then we can go through and add translations to each of those concepts using a CodeSystem supplement without having to go back to the original CodeSystem publisher and to get them to include the translations in their release, which is really powerful. We can also add properties. So for example, if there's a medications code system that we're using and we want to add information about formula information or pricing or scheduling information, then we can do that by adding properties to each of those codes using a code system supplement. One of the things you can't do with a code system supplement is add new codes or delete codes from an existing code system. That's an important restriction. And the way we actually do that is that you set codesystem.content to equal supplement, and then you use the codesystem.supplements field to tell the server what the source code, what the base code system is that this supplement is adding information into. So whether that's LOIC or SNOMED or something off the shelf. So this is a really important mechanism for doing language translations for internationalizing your resources. The second resource we'll look at is the ValueSet resource. So the ValueSet resource has a lot of the same metadata as a code system resource. It has a URL and a version, which is how we identify the ValueSet. And then it's got most of the same metadata resources as code system: name, title, publisher, last updated, status, experimental, etc. The really valuable or the really powerful part of ValueSet, the ValueSet resource, are the compose element and the expansion element. So the compose element is what we use when we're defining the value set, and it allows us to define a whole bunch of rules for which codes are included in the value set and which codes are excluded from the value set. And when we do this, we can draw from multiple code systems, as I said. We can, in the compose, override the display text of the codes that we're bringing in from those code systems. And we can add designations in the ValueSet resource as well. The expansion element of the code system is what we get back when we run the expand operation. So the expand operation is what we use for retrieving all the codes that are a member of a value set, or more commonly for searching for a code within a value set. And when we do that, it's the expansion element that comes back with all of those matching codes inside. So I'll just go into a little bit more detail of how you build the compose element in a value set. So when you're doing that, there are 4 building blocks that you have to work with. The first is all of the codes in a code system. The second is all of the members of some other value set. The third is some list of specific codes from a code system. And the fourth is a filter expression, where that filter expression consists of a property, an operator, and a value. So for example, you might have status equals true, or you might have price is greater than 5, or something like that. And with these 4 building blocks, we can then combine them to build up more sophisticated rules for which codes are included or excluded in the value set. So if we include multiple of these criteria in the same include block or the same exclude block, then they get added together. So for example, we can say only include members of an included value set that satisfy a filter, or only include members of a certain code system that satisfy a filter. Alternatively, if we use multiple include blocks, then these multiple include blocks are ORed together. So rather than saying only members of an included value set that do satisfy a filter, so both of those things apply, we could say members of an included value set as well as any code that satisfies a filter. And we can do that by using separate include blocks. So we can then build up our value set using these things, using many include blocks with different pieces inside them. And then the rule that applies when we're interpreting this is that the includes are always processed first, and then the excludes are all taken out at the end. So that makes sure that it's deterministic which codes are in a value set. There are only two really interesting operations on ValueSet. The first is the expand operation. So this is how we retrieve a list of concepts in a value set. And if we use the filter parameter on the expand operation, it's how we search for concepts in a value set. And then the second operation is the validate code operation. So it's very similar to the validate code operation on CodeSystem. In this case, it tests whether a concept is a member of a given value set. And there'll be more detail about those operations in next week's presentation. So the third resource that we'll talk about, and it's the last resource I'll talk about today, although because someone asked about naming system, I'll touch on that briefly at the end. The concept map resource has basically the same metadata elements as the other resources. It has URL and version when we want to refer to it. It specifies the source and target value set for the map that we're defining. And then within the concept map resource, the actual mappings between the codes are expressed in groups. So a group is a shorthand for a system and a version, for a target system and version and a source system and version. And this saves us having to repeat that code system URI for every source target pair that is probably using the same source code system and target code system. So we can just say it once for the group, and then inside the group, we just say code. In addition to code, we'll also, for each map, we'll specify the equivalence relationship. So I think at the moment in concept map in R4, there are about 8 or 9 or 10 different relationships that can be used between codes. This is a part of concept map that is going to change in the upcoming, or in a future version of FHIR. That's going to be reduced down to a much simpler set. So equivalent will still be there, related to will still be there, and then there'll be narrower, I think broader is staying, and unmapped, I think, is in there as well. The other unmapped element is each of these groups that includes a whole bunch of code to code pairs can have an unmapped instruction at the end. And this says if you try to apply this concept map to a code that isn't mentioned in that group, what happens? And there are 3 things that the group can do for these unmapped codes. First of all, it can just return the provided code. So if you try to translate a code X according to a map and it's got nothing, then you can say, I'll just return the original X that the person passed in to indicate that there was no mapping. So that's one option. Another option is just to use a fixed code. So whatever unrecognized code you get passed in, just return code 3 as a result. Alternatively, you can provide the URI for some extra concept map that is then going to handle the unmapped codes. So you can kind of fall back to another concept map and let it deal with the unmapped codes. So those are the 3 options for unmapped codes in a concept map. The only really interesting operation on concept map, as I said, closure is kind of a concept map operation, but it's really about code systems. The really interesting operation for concept map is the translate operation. And that allows us to pass in a source concept and to determine what target concepts that source concept maps to according to the concept map and with what equivalence relationship it maps. It is possible to use the translate operation in reverse. So there's a reverse parameter that you can pass into the operation, but I'd advise caution with using that. It doesn't mean that the concept map is bidirectional. What it really means is that you're asking the question, what source concepts map to this target concept? You're not asking, what does this target concept map back to? Because it's a subtly different question, and not all concept maps are authored with the desire to be used in bidirectional ways. The other warning I would give for concept map is that it's fairly common to find yourself in a scenario where you need a map between 2 big code systems. Let's say you need a map between SNOMED and LOINC, and you stumble on someone on the web who's done a map. When people build concept maps, and particularly large, complex concept maps, context is very important. So our main experience in CSIRO is that we built a concept map from ICD-10 concepts to, sorry, the other way around. We built a large concept map from SNOMED CT concepts to ICD-10 concepts for the purposes of emergency department billing codes in Australian hospitals. And people often come to us and say, can we have a copy of this map for mapping SNOMED to ICD? And we say, no, this map is very specific to that context. And even if a lot of it works for your context where you want to map your SNOMED codes to ICD, there's going to be cases where the map is wrong because it's wrong for you because it's only right for the Australian Emergency Department billing context. So I'd advise you, if you're taking concept maps off the shelf, be very careful about the context that concept map was intended to be used in, because that's really important when you're using large maps. Before I finish, I'll just mention that some of the well-known terminologies, such as SNOMED CT, LOINC, and ICD-10, have standard mappings of how they're represented as FHIR terminology resources. So, for example, in the case of SNOMED CT, there's a standard set of filters and properties that are available. A lot of those metadata elements are fixed as to how they must appear when SNOMED CT is represented as a FHIR code system. And the same is true of LOINC, of ICD-10, of ICDO, of quite a lot of the other sort of large, well-known standard terminologies. And part of that is restrictive because you shouldn't change how those things are represented. But part of it is powerful as well, because in addition to fixing some of those metadata elements, the FHIR spec also defines what are called implicit value sets and sometimes implicit concept maps. And what this means is that once that code system is loaded into a FHIR terminology server, then not only is that code system available, but there's a huge number of value sets that are just automatically available without having to be created. And in fact, in the case of SNOMED CT, it's an infinite number of value sets, because what happens is that there are these URL patterns that are then available for you to use to reference value sets without having to create them at all. They just have a meaning as a pattern, and they work as if the value set was really defined on the server. So to give you an idea of what those are, with SNOMED CT, the properties and filters that are defined, all of the SNOMED CT relationships, normal forms and module IDs, which if you're using SNOMED CT will mean something, and if you're not, it probably won't. Importantly, the implicit value sets that are defined for SNOMED, there's an implicit value set for all of the codes. And then if you put a SNOMED CT concept ID at the end of this URL pattern here with http snomed.info 5 vs equals ISA, then you're using a value set which is that code and all of its descendants, and that pattern is defined for every concept in SNOMED CT. You can also get the list of all ref sets, which is kind of nice, but more useful is to get all of the codes in a ref set. You can just use this pattern 5 vs equals ref set / and then the ID of a ref set, and that will represent a value set that's all of the members of that ref set. And then there's also a pattern for ECL expressions, and I think Kylin will get into more detail about some of these detailed uses of SNOMED CT in a presentation in a few weeks' time. The same is true of LOINC. So when you use LOINC in FHIR, there's some implicit value sets that are available there based on the multi-actual hierarchy, and implicit value sets for answer lists as well. So these are just value sets that exist without you having to create them. I might answer a couple of questions before I talk a little bit about Ontoserver. So there was a question about naming system. Do you have to create a naming system when you want to use a local code system? You don't. What we've seen with the use of the naming system resource, which is a resource I haven't gotten into here, if you know all of the codes in a local code system and you're able to create a local code system resource, then you usually don't have to bother with a naming system resource at all. Usually you use a naming system resource when you don't know what codes are available in a code system. You just want to make sure that the URL for that code system or the OID for that code system is registered on your server somewhere, and a naming system is a really good way to do that. In terms of AMT, so there was a question of how you map AMT with SNOMED CT. So AMT is actually part of SNOMED CT in Australia. So AMT is no longer distributed separately to SNOMED CT. It's just that however many 100,000 codes there are in AMT, they're just part of the SNOMED CT release in Australia, and they're in the hierarchy, and you can search for them just by loading up that SNOMED CT code system. So it doesn't have to be mapped with to SNOMED CT in Australia at all. It's just they're already in SNOMED. Oh, there I am. The implicit value sets again. So what this means is when you put SNOMED or LOINC into a terminology server such as Ontoserver, and I think Happy supports some of the LOINC implicit value sets. I don't think it supports any of the SNOMED implicit value sets, or not many of them. When you put that code system into that server, there's all of these value sets that are automatically available. They don't exist on the server in the sense that you can't search for them, but you can use their URLs, and you can use the expand operation or the validate code operation, or you can reference them from other value sets, for example, as if they really exist, and they will work to represent all the descendants of a code or all the members of a ref set, as if you had created that value set, but you don't have to create it. So that's why they're implicit. They just exist automatically. So I'll just in 2 minutes, I'll just go through Ontoserver to explain how Ontoserver implements some of this stuff. So Ontoserver implements all of these resources. All of the operations I've mentioned are implemented in Ontoserver as well. All of those implicit value sets that I mentioned for both SNOMED CT and LOINC are available in Ontoserver. Ontoserver is designed to be a turnkey, high-performance, fully featured implementation of the FHIR Terminology Services API, fully featured in that we implement all of the FHIR Terminology Services API. We have specific support for SNOMED CT and LOINC. If you create your own FHIR code systems, which you always have to, then if you create properties and filters, then those properties and filters will work out of the box in Ontoserver. It's designed to be fast enough to support data entry use cases, which means that there's fast value set expansion. There's matching for text filters on codes that returns results in a meaningful order, so that when you put in a search term, a search prefix for a code, then the concepts will come back in a best match order based on a state-of-the-art algorithm that we've been working on for a very long time. It supports general purpose FHIR validation. So any FHIR resource you can send through to Ontoserver to try and validate it. And this is useful because a lot of FHIR resources have coded data in them. And so Ontoserver can check whether those codes match the value sets that the code is supposed to come from for that resource. We have a very, very full-featured implementation of SNOMED CT. We support LOINC. We support multiple versions of every code system. So if you want to put lots of versions in, Ontoserver will use whichever version you say you want to use. And if you don't say which version you want to use, Ontoserver will do generally a very good job of choosing the latest version of the code system. We have a content syndication story that means that you can connect one Ontoserver to another to share content between them in a hierarchical or even just a acyclic graph kind of system. And yes, I'm happy to ask any questions if people want to use their mic to ask questions. We've got just 2 minutes, I think, but I'm happy to answer any questions.
Thank you very much, Jim. It's quite a lot of content that we are going to digest, and it seems like we have a lot of homeworks to study more, and then we will we may have quite many questions. for the audience, anyone have a question in or to ask Jim? Jim is very supportive to our AHIN group on learning the FHIR and terminology services.
Dr. Bunjay,
Yes.
this is Alvin. So my
Yes.
question to Jim is, from the regional perspective like AHIN, should we have one Ontoserver per country connected to each other, or just one Ontoserver for the region available to each country? Over.
I think it really depends on the use cases that you want to support. If you want to support data entry for a large number of hospitals, for example, then I think you'll want many Ontoservers that are close to the hospitals that they're supporting. Whereas if you really want to use it as a single point of sharing a smaller set of reference data amongst the different countries, then possibly one server is useful enough in that case. So it really is a question of identifying the use cases that you're trying to satisfy with the terminology server, whether it's just having a single point of reference for non-runtime use, maybe you just want one server. Whereas if you want everyone using runtime code searching all the time, then you probably want lots of servers all over the place. So it just depends what you're trying to support.
Right. So we can have one regional Ontoserver just as a lookup or a master, and then it gets replicated near the hospitals, which they then use for runtime and data entry.
Yeah, that's a pattern that we've seen used fairly commonly. So most recently, Ontoserver has become the national terminology server for the UK, and they have a single national reference server. It's actually 4 servers, including authoring and stuff. But then they will have other servers in the hospital trusts, and then possibly down at the individual hospital levels as well, depending on what sort of terminology content they want to author down there. And how they want to use the server for runtime use as well.
Okay, thank you. I think the architecture is getting clearer now.
Thank you.
Jim, how Australian implement the Ontoserver, and that is the first question. I'm trying to thinking about the second question. I just lost my mind. Okay,
I'm happy to come back to the second question. So in Australia, the Australian Digital Health Agency took out a perpetual license. So the Australian Digital Health Agency runs a single reference server, which is called the National Terminology Server. And then in Australia, anyone who wants an Ontoserver can get a license for free because of the courtesy of the Digital Health Agency who've bought that national license. And then so anyone in Australia can run their own server for end use in Australia. And then they can pull down content from that national reference server, whether that's the Australian version of SNOMED, or whether it's the CodeSystem for occupations that comes from the Australian Bureau of Statistics, or whatever. They can pull down that content every time there's a new version of the CodeSystem, and they're ready for it. And that's an important point, that none of those people who have their own server have a new version pushed onto them. They always choose when they want to bring down the new version of a CodeSystem, which is really important, because if you're running a hospital, you don't want to automatically have your system changed when there's a new version. You want to run some tests and see whether it's okay before you choose to migrate to that new version. So
that means that the central Australian Digital Agency curate and maintenance all the terminology that used in Australia, right?
That's right, yeah. Well, for the most part. So for pathology in Australia, we use LOINC, and that's produced by the Reagan Street Institute in Indianapolis in the United States. So the Digital Health Agency in Australia published that, but they don't change it at all. Whereas the Australian version of SNOMED, the Australian Digital Health Agency authors that and releases it. And then some of the other code systems that they publish, they author themselves, and some they draw from other government departments, whether it's the therapeutic goods agency or the pharmaceutical benefits scheme or other parts of government produce their own code systems, and the agency publishes them for people who want to use them.
Dr. Bunchai?
Yeah, Alvin, please.
Yeah, so I was thinking that if before we used to just share spreadsheets of data dictionaries, which are really difficult to embed into applications, you can have these spreadsheet data dictionaries imported into an Ontoserver and then make them available programmatically. I think it's like the next level data dictionary and how to make them accessible through APIs. Over. Did I get it right, Jim?
Yes, that's right. And importantly, it's a way to make it accessible, and it's a way to make it easy for implementers to use those things in production. So you take away any excuse for it being really difficult. So what we were seeing in Australia before we had a national server was we had these, well, what we thought were great national terminologies that we wanted people to use, but the vendors looked at it and said, it's really hard. They all have different formats. They all have, even if they're all spreadsheets, they all have different columns, and we have to write code every time that there's a new one. And with the API, we just say it's always the same API call. And the dealing with the different formats of distributions, that's all on Ontoserver or on, the person running the terminology server to deal with that, not the vendor.
Thank you.
My last question before anyone in the call, you can ask through the chat, or you can raise the hand, and now we will let you talk. My last question is how Ontoserver work with the Happy server, and how do you how the architecture that you use in Australia? Like you have many provinces, right? And each province might have some kind of the local context code set or value set that they use. How they manage those? Over.
Yeah, so there's a range of ways that we interact with Happy. We love Happy. Ontoserver is built using Happy. In fact, the Happy libraries are a really important part of how Ontoserver is built. And when you're using Happy as a FHIR server for storing clinical data, so for example, I do that at a university that I work at, where we have integrated the two so that whenever you send a terminology call to terminology request to the Happy server, Happy just passes it on to Ontoserver. So you never actually directly call Ontoserver, you always call Happy, but we've programmed Happy to say, if you get a terminology request, just forward it across to Ontoserver, and then when you get the response, just send it back. So we've done that, and we've also integrated it so that if you do a search for Happy resources that involves some terminology, so you're using that code in or code below style searching, then it will use Ontoserver to handle the terminology parts of executing that query, but it'll search all of the Happy data. So we've integrated that server for that project like that. In terms of each province, each of the jurisdictions in Australia, I've seen some that are using Happy as a store a little bit, but to be honest, in Australia, there aren't a lot of the jurisdictions that are they're not really using FHIR to store clinical data yet. So a lot more of the vendors are, but the states are not as much. So we have vendors like Alcidion, which is a vendor from South Australia who run a EHR and a clinical decision support and analytics platform, and they use FHIR throughout. They don't use Happy, they use the .NET implementation of FHIR, I think. But they use Ontoserver a lot for validating data as it comes into their system. And then they store it in the .NET system once it's inside. So they mostly use Ontoserver for validation.
for the audience, working council, any questions from you or Anis? Any questions from Indonesia or from the Thai team?
Dr. Bunchai,
Uh-huh.
Alvin here, I was thinking maybe we can first talk amongst ourselves and look for a common use case amongst the different countries, maybe COVID, and then we'll go back to the Ontoserver team. Thank you.
Okay. So thank you, Jim. And I think we're going to have a meeting after this webinar, right? So
That's right.
Alvin, could you close the webinar? And then Thai and Australia will have a kind of the a meeting and few Thai standard and interoperability lab Thailand and CSO are going to have a small meeting for the next step.
Thank you.
Over.
Yes, Dr. Butchai. Thank you, Jim and Cicero team. Thank you for your time. We learned a lot. We will be ending the webinar now. So we'll ask the people to please leave the meeting while the Australians and the Thai discuss what would be their next steps. Thank you very much. Goodbye.